Hello, and welcome to this TE Connectivity webinar. My name is Katie, and I will be your Global Spec moderator. Now let me introduce today's presenters. With us today is Bill Irwin and Devin Brock. Bill is the Senior Manager of Business Development for Medical Sensors. Devin is the Manager for Sensors Product Knowledge and Training. To read more about Bill and Devin, please look at the speaker bio window right next to the main presentation window. And with that, I'd like to pass things along to Bill and Devin to get this webinar started. Gentlemen, go right ahead.
Good morning, good afternoon, and good evening to everybody around the world. And welcome to the Rise of Telemedicine webinar. My name is Bill Irwin, and my colleague Devin Brock and I would like to thank all of our attendees for the opportunity to present this topic to you today. Today we will cover several topics, including what is telemedicine, what are some of the benefits of telemedicine, how is the technology growing and evolving, the importance of sensor data to support this technology, some of the new things evolving in telemedicine, sensor technologies enabling that growth, and then we'll go through a couple use cases, and of course we'll leave time for question and answer. So if we were to poll a group of patients, I believe we would get very different answers to the question, what is telemedicine? So just to baseline all of us today, for the purpose of this discussion, we're going to use a definition that telemedicine is the diagnosis and treatment of patients using audio and or video communications instead of an in-person visit. When we think about telemedicine, it's important to recognize there were trends that existed pre-COVID. There was an acceleration of telemedicine due to COVID, and then there's the future of telemedicine. Pre-COVID, more than 50% of healthcare organizations had a telemedicine program, and most of the rest had one in the works. Telemedicine quickly became a popular option during the pandemic because it limits the risk to doctors and patients. In 2020, we experienced spikes in regional demand for medical services that overwhelmed the system. Telemedicine allows patients to connect to medical professionals that could be in other regions. As a result, virtual visits increased 134%, and revenue from these visits increased 64% in 2020. There's a belief that telemedicine is a trend that's here to stay. Forecasts have visits growing another 70% in 2021 versus 2020. On this slide, we will discuss the benefits of telemedicine. On the last slide, we discussed the incredible growth in the industry in 2020 and the bright projections for the future. What drove this growth is a compelling value proposition to both the patients and the doctors. Most of the benefits were there pre-pandemic. The pandemic caused a paradigm shift, accentuating these benefits and removing some of the legislative barriers to create this inflection point. A few of the benefits of telemedicine are that it limits the risk to immune-compromised patients and medical professionals during a visit. Let's face it, one place you're likely to come in contact with a sick person is at the doctor's office. It makes it easier for patients with limited mobility to see a doctor. Some patients may not drive and need to arrange transportation, or may need to use public transportation for an in-person doctor's appointment. It saves time for the patient and for the doctor. Patients have no commute time to and from the visit. And for doctors, software can help schedule their day and keep it on pace. Finally, telemedicine connects patients to doctors who are outside of their local area. This can be for a specialist visit. I'm sure you or a member of your family has had to visit a specialist. Specialists may not be located in your same town and may involve a lengthy commute to and from the visit. So telemedicine certainly limits that. And the second would be for convenience. If I'm sick today, I want to see the doctor today and not hear from my local provider that the first opening will be at 4:30 in the afternoon tomorrow. On this slide, we'll discuss the benefits of remote monitoring. Remote patient monitoring allows doctors to see patients' vitals in a natural setting rather than a spot check. When doctors only get points of data, it can be difficult to understand the full picture. How do you distinguish patients who may get nervous during a visit or may have just finished a stressful event from somebody who has high blood pressure? Remote monitoring gives doctors access to that complete picture. Remote monitoring can also drive down the cost of healthcare. It can enable patients to go home from the hospital earlier and still be monitored by medical professionals. In this next section of the presentation, we'll go through the evolution of telemedicine. I'm sure I have some parents on the line today, and if you're a parent, I believe you probably had to call the after-hours helpline at your children's pediatrician to consult about the condition of a sick child, maybe how to handle a high fever in an infant, how long to let it go, and when you should take the next step and take them to the hospital. While this slide is about video chat, I believe that audio portion is where many of us started. As we got into the pandemic, many people then progressed into a video format for checkups with their doctor. So this next level of device starts to add more of that objective level of data into the visit with the doctor. And these are really comprehensive exam kits to be used with telemedicine. So first off, to take a step back, to diagnose and treat patients, doctors certainly require data. And to make that data usable, it needs to come from a device that's regulated by somebody like the FDA, the EU, or other regulatory bodies around the world. And that kind of starts when we get those devices us into the next stage. And it involves more ability to exchange data and information to be able to do a complete examination of the patient by the doctor. So these kits come in many forms, but the commonality among them is it's something that the patient can use in conjunction with the video visit with the doctor in the comfort of their own home. There's some of these available here in the US at big box stores that could be purchased for hundreds of dollars. And there's also the possibility of kits like these being essentially loaned to patients to use during the visit that would then be shipped back sterilized prior to going to the next patient. So these remote exam kits contain the necessary items to capture things like blood pressure, temperature, to listen to the patient's heart, their lungs, to examine throat, ears, skin, and many more things. One thing I think we can say for sure with any of these kits and the ones in the future is we've probably only begun to scratch the surface of what medical professionals will be able to do remote in the future. Other companies are taking a fundamentally different approach to telemedicine, and they're developing kiosk-type exam rooms or cart-based examinations. These booths provide secure video and data connection between doctors and patients. Inside are all the devices that are required to gather things like your weight, temperature, blood pressure, blood oxygen levels, listen to heart and lungs, and perform many visual examinations. Doctors can direct patients on which devices to use to gather the information they require to complete their diagnosis. And this can be done with either a family doctor or a specialist. One of the things that's interesting about these booths is they could be placed anywhere, like inside a drugstore, to facilitate the one-stop shop, go for both your examination and your prescription filling. It could be placed somewhere like a shopping mall or a grocery store to make it somewhere that people are going on a regular basis. Or imagine the future of your company having one of these within your own office and being able to go to a doctor's visit without leaving the workplace. Wearables are a new way to exchange information between patient and doctor. As we covered earlier, for a doctor to use the data to diagnose or cure, it needs to be gathered by a medical device. Companies are developing high-quality wearables that are also medical devices. You may be familiar with or own a smart or fitness watch that is 510(k) approved from the FDA as a medical device. The device is only part of the system. The other is a secure platform that gives doctors access to patients' health data. These systems may use artificial intelligence to catch abnormal patterns within a patient's data prior to a serious event occurring. They can alert the patient, the doctor, or both that action needs to be taken. For the next section, I'd like to turn it over to my colleague, Devin.
Thanks, Bill. We wanted to take a little bit of time and talk about what physiological data sensors can measure. Sensors are used to measure and monitor a wide range of patient data, including things like heart rate, blood pressure, blood oxygenation, body temperature, weight, and respiration rate. Physiological information like these can be logged to provide a single measurement point, or the data can be stored to allow for medical technicians to look at trends or anomalies in data over time. Also, more complex data like sleep patterns and even information on exercise or movement patterns can provide useful information to the doctor or a medical technician. Additionally, environmental information can also be logged that can help paint a more complete picture of the patient's surroundings, such as room temperature and humidity, altitude, and much more. To make telemedicine technologies function properly, the collection and measurement of accurate data is essential. Therefore, sensors play a very key role in telemedicine growth and the patient's benefits which it delivers. Sensors are a key element to telemedicine as they provide important data to the medical clinician and allow them to obtain an accurate and complete picture of the patient's health. Sensors not only need to provide accurate data, but the sensors themselves must be reliable and durable. Home medical equipment is designed to be both durable and easy to use. Much of the equipment is designed to be portable and either battery operated or rechargeable, which requires sensors that are both as small as possible and low power. The move to microcontroller-based systems with a standard bus architecture has driven more sensors to implement digital output options. TE Sensors has a broad portfolio of sensor technologies, many of which apply directly to medical applications and specifically to the rise of telemedicine. Applicable sensors include products from the following technologies: pressure, temperature, piezo, photo-optic, and force. Moving forward, we will look at each of these technologies and showcase some specific products and their use cases in the telemedicine field. TE manufactures a wide range of pressure sensor models, including surface mount and board mount designs, as well as modules and transducers. The addition of silicon microstructures and first sensors has significantly expanded TE Sensors' portfolio into lower pressure applications, some of which are common to telemedicine. Shown are three specific models: the MS58 series of surface mount sensors, the SM4000 medium pressure analog digital sensor, and the 1620 invasive blood pressure sensor. Key applications for these pressure sensors in the telemedicine field include blood pressure cuffs, spirometry, as well as smartwatches targeted to physiological measurements and fitness tracking. On the temperature side, TE has a range of analog and digital thermal elements, some of which have been designed specifically as a non-contact sensor measuring body temperature. Additionally, TE manufactures a range of surface-mount digital temperature sensors with a range of accuracies with footprints down to 1.5 millimeters square. TE also has a long history of NTC sensor products for medical applications, including ones for monitoring skin body temperature. TE's 400 and 4400 series of disposable and reusable medical probes a 510(k) approval, which makes them easier to integrate into finished telemedicine products. On the application side for telemedicine, TE sensors are involved in products such as non-contact and contact thermometers, smartwatches, as well as products that can accurately monitor room temperature and other parameters. TE Connectivity's piezoelectric sensors provide durable elements for a wide range of medical applications. Piezo sensors and transducers are available in various forms, including film, cable, and miniature elements in standard and customized packages. Although the technology is not well known, the unique properties of piezo film as a dynamic strain sensor make it well suited to the detection of vital signs, whether mounted in direct contact with the skin or mechanically coupled through intervening layers. Piezo technology can also be used as a contact microphone for smart stethoscopes or for respiration rate monitoring, and can also be embedded in beds and mattresses as part of a sleep monitoring system. From patient monitoring in hospitals to wearables and home healthcare applications, TE's photo-optic sensors and components are key parts for non-invasively measuring blood oxygenation, or SpO2 level. Low oxygen levels can be an early warning sign that medical care is needed. Many people with COVID-19 and other similar illnesses have low levels of oxygen in their blood, even when they feel well. Force sensors, also referred to as load cells, are used in a variety of medical applications, including fusion pumps that deliver fluids, such as nutrients and medications, into a patient's body in controlled amounts. Some are designed mainly for stationary use at a patient's bedside. Others, called ambulatory infusion pumps, are designed to be portable or wearable. They can deliver nutrients or medications such as insulin or other hormones, antibiotics, chemotherapy drugs, and pain relievers. Other applications for force sensors in the telemedicine market include grip strength for physical therapy and related applications, and as sensors for smart weight scales. Bill, now back to you to discuss a unique use case utilizing TE sensor technology.
Next, I'd like to share with you a development from the engineering team at TE. In this video, you'll see an application of our piezo film sensing technology. This film is thinner than a sheet of paper and can be placed inside items like a chair or a hospital bed. In combination with the right analysis and processing, it can gather occupancy, heart rate, respiration rate invisibly to the patient. No effort is required from the patient other than sitting in a chair or lying on a bed. This next section, you'll see where some of the sensors are placed throughout this device to help us gather this information about the patient. In the next section of the video, you'll see the person demoing the chair simulate an increased respiration rate. Increased respiration rates could alert somebody in a medical setting that the patient's anxious or has an immediate need. And then you'll see that return to normal as he relaxes. This next section, when the patient starts fidgeting about, there will be a detection of both the fact that there's increased motion, and then you'll see the heart rate increase as well due to the motion from the patient. And then finally, when he gets up out of the chair will indicate that it's no longer occupied, and you'll see the vital signs drop off. One of the challenges with telemedicine is that patients, rather than trained professionals, gather data. For telemedicine to succeed, it requires accurate measurements from devices that are easy to use. As was demonstrated in the video, this system can be used to indicate occupancy in telemedicine or an emergency room, a doctor's office, or other facility, and gather meaningful patient data. Imagine if your local emergency room had these chairs in the waiting room. A nursing supervisor could see remotely that the ER was full and that more staffing was needed to deal with an influx of patients. Nurses could pre-screen patients and prioritize those with an erratic heartbeat or respiration rate. In a kiosk-type telemedicine visit, the chair could alert the doctor that the patient is present and gather initial information about them. At TE, we're excited to demonstrate invisible monitoring capabilities, and we want to talk to you about ways our sensors can help make data gathering easier. At this point, I'd like to turn it back to my colleague Devin to run through some more use cases.
Thanks, Bill. Two use cases where sensors are being utilized in telemedicine applications include a pressure sensor as part of a home-based system for checking and storing blood pressure measurements, and a thermopile element as part of a non-contact temperature system for checking body temperature. In the first application, home medical companies are developing diagnostic systems that can accurately and reliably measure and store blood pressure readings as part of an at-home examination or as part of a daily routine for patients. Blood pressure is an early warning sign for medical issues, especially for older patients or those with other underlying medical conditions. Studies show that blood pressure measurements taken at home can be more accurate and indicative of a patient's true blood pressure, as it eliminates the white coat syndrome that can elevate a patient's blood pressure strictly due to the anxiety of visiting the doctor. The board-mount pressure sensor is used to read pressure pulses from the patient and translate those into a blood pressure reading. Much research is being done by medical companies to read blood pressure in cuffless systems while still maintaining high accuracy and repeatability. In the second case, a thermopile is used as part of a body temperature reading instrument. The non-contact temperature system can be used as a standalone instrument to read body temperature, or as part of a broader diagnostic system that can read and record other patient information, including heart rate, blood pressure, lung function, and more. Temperature is a well-known indicator of possible infections and oftentimes is used as one of the screening methods for an array of medical conditions. Two real-world use cases where sensors are being utilized in telemedicine applications include a piezoelectric-based microphone as part of a smart stethoscope and a piezo film sensor used in a respiration monitoring patch. In the first application, home medical companies are developing diagnostic systems that are designed to allow an at-home examination of a patient's ears, lungs, heart, temperature, and more. The systems are designed to walk the user through a series of simple steps to obtain physiological data of themselves or another person that can be transmitted live to a remote physician, or that can be stored and transmitted at a later time as part of a remote office visit. The physician can then provide a diagnosis and provide recommended treatment and/or write a prescription for the appropriate medication. The piezo-based microphone is used to listen to the patient's heart or lungs and can accurately record data that can then be analyzed by the doctor. In the second case, a patch of piezo film is used as part of a respiration monitoring patch. The patch is part of a system that transmits respiration data wirelessly to an application that monitors and stores the information. Respiration rate is an important indicator of a patient's health. Recent evidence suggests an average adult respiratory rate is 20 breaths per minute. However, this changes when a patient is sick or critically ill. The sensor is located within a patch that uses a medical-grade adhesive that adheres to the skin for up to 5 days. They are often used in hospital settings to monitor at-risk patients, but are moving into a home-based setting to monitor patients with mild symptoms from illnesses like COVID-19 that may worsen over time and would then require different treatment or hospitalization. The piezo sensor is used to monitor inhalation and exhalation and translate those lung functions into data that can be easily and accurately deciphered by medical personnel. The last two real-world use cases we will cover today where sensors are being utilized in telemedicine applications include a board-mount pressure sensor as part of a digital spirometer and photo-optic sensors being used in a smart pulse oximeter in a telemedicine kiosk. In the first application, medical companies are developing smart digital spirometers that are designed for teleconsultations with respiratory therapists, allergists, pulmonologists, or general practitioners. These can be standalone units or can be used as part of a larger telemedicine platform. Respiratory flow can be accurately measured using differential pressure sensors. The patient's breath flows through a laminated flow element or a screen with a very small flow resistance. A minimal pressure drop results over the element, this representing a measure for the respiratory flow rate or the respiratory volume per time. These differential pressures can be logged with a highly accurate sensor and converted into an electrical signal. The nose clip is typically used to improve the accuracy of the measurements, and special software guides the user through the process and helps ensure the patient is using the spirometer correctly. The second application involves pulse oximetry. Many people are familiar with pulse oximeters that are used in doctors' offices and hospitals, as well as the inexpensive units available for sale directly to consumers via online retailers. The big difference between the two types of units is the accuracy and repeatability the medical-grade units have. The major telemedicine providers are working hard to breach that divide and provide more accurate and reliable pulse oximetry sensors for home telemedicine use, as well as in kiosks. Many devices are wireless and connect directly with the home telemedicine system or the kiosk. Photo-optic sensors usually consist of an emitter that transmits light in well-defined wavelength, as well as a match detector. TE manufactures both the sensor components as well as complete assemblies that are designed for applications that require a high degree of precision, durability, and performance. TE provides many ways to connect with us, to find the data that you need, and to get answers to questions that you might have concerning products, applications, and much more. From our website at te.com to live chat that is available 24 hours a day, 7 days a week, TE provides many ways to get the information you need. Additionally, find us on social media, including Facebook, Twitter, YouTube, Instagram, and more, and learn more about TE and how we are connecting the world.
Okay, great. Thank you so much, Devin and Bill, for that great presentation. We do have some questions that have come in from our attendees, so we are going to move into answering those right now. So, gentlemen, the first question for us today: are TE sensors for the medical market different than those used in other markets?
Okay, Katie, this is Devin. I'll take that one. So, yeah, it's a great question, and yes, there are some differences. So, for example, first, the range and accuracies tend to be specific to a medical application. So, for example, a temperature sensor that's monitoring body temperature needs to be very accurate, but only over a very, very narrow range. So, for example, around body temperature, so around 98 degrees Fahrenheit. Also, there are requirements for things like the ability to sterilize or disinfect that can impact the construction of the sensor itself. And then finally, there are things like industry requirements like ISO 13485 that can impact things like the manufacturing and quality policy. So yes, there are some differences. There are many similarities, but again, there are some differences in terms of sensors that are used for the medical market.
Okay, Devin, thank you so much for that answer. Next question here, Bill, I think this one's going to be for you. What differences would there be for sensors for telemedicine versus those used in hospitals or other healthcare settings?
Yeah, another good question, Katie. So at a high level, there's not a lot of difference. As Devin mentioned, there's specific ranges that we're looking at for something like temperature or blood pressure. And those are going to be very similar. The industry requirements are also going to be the same. What we do see is that the devices that are used in telemedicine really benefit from being intuitive to use and rugged, since it's patients rather than trained healthcare professionals that are going to be using the devices.
Okay, great. Thank you so much, Bill. For all the attendees, if you do have a question for Bill or Devin, go ahead and place it into the Q&A window and click Submit, and we will move through as many questions as we can. Okay, Bill, I think this next one is also for you. Are TE sensors capable of being sterilized or wiped down between uses?
Yeah, another good application question. So many of our TE sensors can withstand a wipe down or sterilization. At TE, we think the important thing to do is really to align with our customers at the start of any project on what their requirements are. So we ensure that we're selecting a product or designing a product that performs to the application and the environment that the customer needs.
Okay, great. Thank you so much for that answer. Next one here, Devin, I think we're going to go back to you for this one. What trends is TE seeing in regards to the sensors market relative to IoT, Iomt, and telemedicine?
Okay, Katie, yes, I can handle that one. So in terms of the trends in telemedicine, they're similar to the market in general. So namely things like miniaturization, so things are getting smaller and smaller. Digitization, so moving away, not so much from analog sensors, but moving to where you can have digital sensors that are either I2C or SPI or protocols like that. Things like low power, so sensors are getting lower and lower in power, and that's especially important for applications where things are battery powered. So a lot of telemedicine, especially home telemedicine products, are battery operated, so being extremely low power can be very helpful. And there's things like multi-sensor modules, so the ability to combine sensors, sensor technology, so things like temperature and pressure, temperature and humidity, and those sorts of things. So anytime you can combine sensors into one module, typically will make them easier to use, will make them less expensive, and also will provide critical information that, again, if you had to have more than one sensor, makes it harder to put into the application and things like that. So those are a couple of the ones. There's also some other ones that are out there in terms of what else you see. So the ability to handle harsh environments, and for harsh environments on the telemedicine side, that's maybe a little bit different than the industrial side. But again, there's going to be cases where these things need to last many, many days, many weeks or months. And again, how they're handled, of course, is going to be a little bit different in a home setting or in a setting where there's lots of different people around there. So generally speaking, the sensors are going to have similar requirements to those used in hospitals and other healthcare facilities, but oftentimes these products will need to be, the end product will need to be more intuitive in terms of how it's developed. So again, there's not going to be experts that are handling them, but also you will see instances where the parts need to be either disposable or replaceable, the sensors, that is. So again, there's, many of the trends are the same, but again, there are some key differences there. Back to you, Katie.
Okay, great. Thank you so much for that answer. And reminder to all the attendees, if you do have a question, go ahead and place it into that Q&A window and click submit. We will do our best to get through the questions today. So Bill, I think I'm going to stay with you for this next one. Are telemedicine companies developing their own devices or using devices from OEMs?
Okay, thank you. I think when we look at the systems today, it's a bit of a mix, but I think that the big early push in the industry is how do we develop the architecture for a telemedicine system more than devices? And what I mean by architecture is companies need the secure platform to connect the doctors and the patients together. They need a good network of doctors that are going to cover, everything from general medicine to the various specialities. They need the coverage from insurance companies, and they need to be accessible to patients, whether that's in a kiosk or in a home setting. And so some of the consumer-targeted systems, the ones that are more meant for the home setting, I think we do see some incorporation of sensors into the device, but the device kind of doubles as both the system architecture and the device. I think what I've seen in some other industries when I look at things like robotic surgery, usually the first push is to develop that architecture, and the second push is companies start thinking more about how can we provide end-to-end services.
Okay, great. Thank you so much for that answer. Our next question here, one attendee is asking, where would they purchase a TE telemedicine device? Would it be prescribed by a doctor and then purchased prior or to the telemedicine visitation? Just asking kind of where they can get it.
So I'll take that one. So TE, we're actually not a device manufacturer. We partner with medical device companies to bring these technologies to market. So from knowledge of the systems, I think there's certainly, if you're in the U.S., there's some available at big box stores, places that might sell electronics would be a place that you could purchase those types of systems.
Okay, great.
Right,
Thank you so much. All right, another attendee is asking, what kind of devices are necessary to receive and collect data from all activated sensors on the doctor side? Is there any secure medical portal or server system to view data from the sensors?
Yeah, I'll take that one as well.
Oh, go ahead, Bill. Yep, how about it?
Yeah, so typically these systems are set up so there's a reciprocal system on the other side that the doctor's seeing. So there's absolutely a secure link between the two. And the doctor's, seeing similar information as what the patient's seeing on their screen as far as the readings of the devices.
Okay, great. And then kind of sort of a follow-up to that, this person's just asking, is there an app to connect to the smartphone? So again, kind of how they're able to see the information.
Yeah, I think that depends on the system itself. But, certainly there are smartphone-based app systems out there. Some of them add sensors onto the phone or connect via Bluetooth to the phone and then connect to the doctor via an app.
Okay, great. Thank you so much for those answers. A reminder to the attendees, if you do have a question for Bill or Devin today, go ahead and place it into that window and click Submit. We will do our best to get through the questions today. Another attendee is asking, who will help the patients on how to use the sensors properly?
I guess
Good
I can
question.
handle that one. Yeah, go ahead, Bill, if you like.
Oh, go ahead, Devin. I've been on a roll here, so you take this one.
Okay. Yeah, no problem. So really in terms of how the sensors are used, again, as we kind of mentioned before, really we're not involved in the end product per se. It's really up to the device manufacturer, again, to determine and to write the instructions and those sorts of things to make it easiest for the patient to use it. So again, our job is to make it easy to interface to the sensor, to make them rugged, reliable, and to work effectively for a long period of time. Again, something that the device manufacturers are working diligently to make sure that these devices are very simple to use. Again, they recognize that these are not doctors and clinicians that are using them, that these are normal patients. So I think it's very much like Fitbit and some of the other home devices that people use. So people recognize, the manufacturers recognize that they have to go to an extra step and make them one easy to use, also to supply the ability to call up and ask questions and those sorts of things, and also with the doctors and the people on the other side to help their patients if they have any issues with them. So again, there are some issues that are out there, and again, they're being addressed on the device manufacturer side.
Yeah, so I'll just add to that if I can a little bit. I would also say one of the benefits of this being telemedicine and being in the video chat with the doctor at the same time, right? It's like if you're using a video chat service at work, the doctor can see where you're placing the sensor, how you're using the device. So certainly the doctor can help guide the patient through proper placement and use of the devices.
Okay, gentlemen, thank you both so much for that answer. So next question here, Bill, this one may be for you. What sensor characteristics are important for sensors used in telemedicine?
Okay, so, a couple that kind of quickly pop to mind would be something that's number one, robust, as we have those users that aren't as familiar with the devices. Big one is accuracy and repeatability. And then really the last thing I would think about for these would be the ability to be disinfected between uses. They're probably going to be subject to some type of wipe down in between patients just to make sure that we have a sterile environment for the next user.
Okay, thank you so much for that answer. A reminder to all of our attendees, if you have a question, go ahead and place it into the Q&A window and click submit, and we will try to get to your question. I also just wanted to point out in the resource widget, we have a lot of great resources there for all of our attendees. Before you leave today, go ahead and take a peek at those, and you can take anything with you today on your way out that may help with any of the questions that you're having right now as well. All right, gentlemen, back to a couple of our last questions here today. This next one, what level of experience does TE have in designing and manufacturing sensors for medical applications?
Yeah, so TE's been designing medical sensors for decades. We have design teams and manufacturing teams that are located in really all the regions in Americas and EMEA and Asia Pacific. And those teams will work with our customers to design and manufacture in the region that our customers need to work.
Okay, great. Thank you so much for that answer. So if any of the attendees have any more questions, go ahead and place them into the window now and click submit. Gentlemen, this is going to be our last question today unless we get any others that pop in right now. So I'll give everybody a minute to kind of enter in their last minute questions as we answer this last one right now. So gentlemen, this is a nice one to kind of end on, and it is a little bit connected to one of the ones that we did answer before, but still a good question. Are TE sensors available through distribution?
Okay, yes, I can. This is Devin. I can handle that one. So in terms of distribution, yes, I mean, our sensor products are available through, really a wide range of both catalog and specialty distributors. And those are distributors that are, that are well-known and are available throughout the world. So again, regardless of whether you're in EMEA, Asia Pacific, or the Americas, there is going to be a distributor where these types of products are going to be available directly through them. And again, although we deal with, OEM manufacturers for the most part, we do our best to make sure that our products, especially our standard type products, are available through distribution. So I'll turn it back to you then, Katie.
Okay, great. Thank you so much for that last answer. And we are going to wrap up the webinar right here. I want to say a huge thank you to Bill and Devin for a great presentation and for sticking around to answer some of our attendees' questions. So, gentlemen, thank you both.
Yes, thank you, Katie, for all you did, and thanks to everybody for joining us today.
Yeah, I'd like to certainly take a minute to thank all our attendees for taking some time to spend with us today. In medical, we get an opportunity to impact the lives of our family, our friends, and even ourselves in a positive way, and really look forward to connecting with you to enhance medical experience for the patients. So thank you to everybody, and thank you, Katie, for the great forum to connect with everybody today.
All right. Thank you both, Bill and Devin, so much. And like we were saying, a huge thank you to our audience members for being part of this webinar event. Take care, and we will speak with you soon.